In this segment, we'll go over why that's such a big deal. But first, if you haven't already, please subscribe to Best Practice so we can keep more information like this coming your way. One way to think of cells is like an island, but they're not some tropical island just chilling in the ocean full of interesting parts that have colorful names like mitochondria and Golgi apparatus. Life is work, and cells get that work done. The main job of most cells is to use DNA as a blueprint to assemble proteins out of amino acids. Protein synthesis. Proteins are the structure of almost everything that happens. Need a new cell? Proteins replicate the DNA through cell division. Worked out and muscle needs to be repaired stronger? Proteins. What about communication? Need to tell the next cell what's going on, activate its receptor? Well, what's that receptor made of? Protein. Whoa. A cell gets most of its input through the activation of receptors, and receptors are made from proteins. That means a cell's input is controlled by the shapes of the proteins they make. Now, proteins don't exist in nature like a long garden hose stretched over your front lawn. In nature, they're folded up, wound, bound, and it's the three-dimensional form that's the key to their function. So if you wanted to change the way a cell was acting, and you knew the 3D shape of the protein that made up its receptor, then you would know what chemicals could be used to deliver that to that receptor to get the change you wanted. There's a name for chemicals that bind to protein receptors and change the cell's function in a desirable way. Those are called drugs, pharmaceuticals. Starting to see why knowing the three-dimensional structure of every one of the hundreds of millions of proteins on Earth is such a big deal? Moving forward, we'll be able to develop drugs to target specific cell receptors with accuracy that would not have been humanly possible for the foreseeable future, thanks to artificial intelligence. In the next segment, we'll go into depth about the ramifications and potential of such a monumental discovery. So stay tuned. I'll be back.